Believe it or not, the sun was not always accepted as the center of our solar system. In fact, for thousands of years, many elite scholars, philosophers, mathematicians, and astronomers assumed that the Earth served as its focal point. This is called geocentrism. Geocentrism is a model of the universe that describes the Earth as the center of the cosmos. Most ancient scholars seem to buy into this idea. Well-known philosophers such as Plato and his student Aristotle are a few who endorse the idea because it seemed like the best solution for the structure of the universe, given what they could see and understand at the time. When these ancient astronomers looked up at the skies, they saw that the stars and other planets moved. They observed that the sun and the moon both rose and set, further fueling their belief that they must be rotating around the Earth. The most elaborate and in-depth support for geocentrism came from an ancient astronomer named Ptolemy, who lived in Alexandria from around 100 to 168 AD. His model mathematically described the structure and function of our universe. He started by making a few assumptions. First, the heavens were spherical and moved circularly. Second, the spherical Earth was at the center of the universe. And finally, the Earth was immovable. Once these were assumed, Ptolemy could begin constructing his model. When making observations about planetary motion, he noticed strange looping behavior of the planets. This kind of motion is called retrograde motion. In order to account for it, he employed three devices. He needed to use an epicycle on deferent system to describe planetary motion. The deferent is the large circle on which the epicycle, the smaller circle, rotates. A planet moves along the epicycle, which moves along the deferent. At the center of the deferent is a point called the eccentric. In Ptolemy's model, the Earth is located just a small distance away from the eccentric. His system therefore required the placement of an equant, a point that was directly opposite of the Earth at an equal distance from the center of the deferent. Altogether, the employment of the equant, eccentric, and the epicycle on deferent was useful in explaining the variations in speed and brightness of the planets. As we know today, the Ptolemaic model is faulty. Countless scientific observations and mathematical proofs have shown that the sun is the center of our solar system. But this isn't to say that the Ptolemaic model is completely useless. In fact, for many centuries to follow, it would serve as an important stepping stone for many philosopher astronomers. But before we get there, let's rewind a few centuries. A different proposal emerged during this time, and this proposal suggested that the sun is the center of the universe. This is called heliocentrism. It can be traced back to a duo of Greek philosophers from the Pythagorean school named Philolaus and Hyktas. The duo proposed in the 5th century BC that the Earth revolved around some central fire, whatever that may be. However, because scholars are unsure about the legitimacy and even the existence of these two philosophers, credit's often given to a different guy, named Aristarchus of Samos. He is deemed by many as the true discoverer of heliocentrism. Aristarchus's model was a bit unusual for the time. It challenged the status quo, and to many of his colleagues, it was unperceivable. See, these companions of his model was a direct violation of stellar parallax. Stellar parallax is the phenomenon that explains the apparent shift in the position of the celestial body relative to the fixed stars. So, while he could have just simply said that the stars were so far away, stellar parallax was irrelevant, this kind of distance was unfathomable at the time. So Aristarchus was not able to successfully defend his view. The model was unfortunately dismissed and not legitimately reconsidered for a long time. So, perhaps most notably, the true discoverer of heliocentrism is Nicholas Copernicus, and honestly for good reason. Copernicus was a genius mathematician and astronomer. In 1512, he published the Commentariolus, in which he explained his heliocentric model. Copernicus' system relied on 4 basic assumptions. First, he noted that the celestial bodies revolve around the sun. Second, the fixed stars had to be very far away. This would settle any concerns about the stellar parallax by suggesting that the human eye would not be able to observe it. This is what Aristarchus needed to do. Third, the Earth turned on its own axis. Finally, he assumed that the annual motion of the sun was caused by the Earth's motion of revolution around the sun. These assumptions would mean that the Earth was no different at all from the other observable planets. In his system, variations in brightness, in speeds, and in distances of all the planets were all accounted for. He was able to almost completely abandon Ptolemy's use of epicycles, and he could disregard completely the eccentric and equant, which he hated, and he could still account for the apparent retrograde motion. Many astronomers studied Copernicus's model. The young German mathematician and astronomer Johannes Kepler noticed observable faults with circular motion, which Copernicus's model heavily relied on. This bright scholar would instead refine the Copernican model by suggesting that planets actually move with elliptical orbits. I cannot express how revolutionary this idea was. But that wasn't all that he recommended. He also noted that the speed of a planet's movement is related to the planet's relative distance from the sun. Another important scholar from Italy, Galileo Galilei, used telescopic discoveries to prove the Copernican model. He discovered that there were moons on Jupiter, sunspots, and phases of Venus. These were all very, very important and very controversial ideas for the time, but that didn't stop Galileo Galilei from seeking the truth. A little bit later, in the 1600s, an English mathematician named Sir Isaac Newton would also propose some phenomena that would help explain the Copernican model. He suggested 3 laws of motion and the law of universal gravitation, which helped explain why the planets move the way that they do. All in all, these astronomers were very, very important in confirming the heliocentric model. So where does that lead us? Well, the history of heliocentrism certainly is complicated, but it's also really important to know. Its development was dependent on the discoveries of several elite thinkers, and they date back all the way to the 3rd century BC. Their contributions were so important, and they were so necessary to understand the way that the world as we know it functions and the entire structure of our solar system.